hope you guys are excited for this next chapter of one shot in physics, that is thermodynamics, right? So आज हमारा जो चक दे सीरीज है उसका सेकंड चैप्टर हम स्टार्ट करने वाले हैं. अगर आपने फर्स्ट चैप्टर अभी तक नहीं देखा है गाइस, so go and watch that session also, but of course after this session, है ना, वहां पे हमने वर्क, एनर्जी और पावर किया था. यहाँ पे हम थर्मोडायनेमिक्स करेंगे. Why we are doing thermodynamics बच्चों? तो the simple reason is कि इसका जो weightage है that is approximately 9% in NEET exam, right? The weightage is approximately 9% in NEET exam. ठीक है, तो बच्चों that is why this chapter is very important और इस पूरे चैप्टर को आज हम one shot में complete करेंगे, right? And guys, my name is Vibhati and welcome to Infinity Learn by Sri Chaitanya. तो सबसे पहला काम चैप्टर स्टार्ट करने से पहले बच्चों, अगर आपने सब्सक्राइब नहीं किया हमारे चैनल को तो फटाफट से सब्सक्राइब कीजिए, बेल आइकन प्रेस कीजिए ताकि आपको बहुत सारे चकदे सीरीज के बहुत सारे लेक्चर्स होते रहते हैं, वो सारे लेक्चर्स मिले, आपको इंपॉर्टेंट अपडेट्स मिलती रहेंगी रिगार्डिंग नीट और जेई एग्जाम. तो बच्चों डोंट वरी, वी आर हियर फॉर यू. लेकिन आपको बस एक ही काम करना है, सब्सक्राइब टू आवर चैनल एंड प्रेस द बेल आइकॉन सो दैट you'll get the notifications. ठीक है, so let's start चक दे पार्ट 2 for physics, that is thermodynamics बच्चों, right? So hello everyone, hi Sai Vignesh, hi केसी रेड्डी, hi वैष्णवी, hello बच्चों. All right, okay, चलिए. Now I'm able to see your comments बच्चों. Yes, चलो एक मिनट, just give me a second बच्चों. ओके, हेलो, हाय तेजा, ठीक है. All right guys, so we are studying thermodynamics in today's session बच्चों. Let me tell you one more thing before starting this session कि thermodynamics में there are a lot of formulas, ठीक है. You should remember all the formulas, and there are lots and lots of definitions in this chapter. You should remember all the definitions and all the formulas. If you look at the past 30 years के question from thermodynamics, all the questions are from the definition and the formula directly, right? So like in this chapter, questions are more theoretical as compared to the numerical portion in previous NEET exams, right? So try to remember all the information that I'm giving you in this session. इस session की हर slide पे जो एक line है, that is very important बच्चों. So try to remember each and every concept of this chapter, ठीक है? Fine, all right. So let's start with thermodynamics. Thermodynamics होता क्या है? Thermodynamics is the branch of science that deals with the exchange of heat energy between two bodies, okay? And it also deals with the conversion of heat energy into mechanical energy and vice versa. We'll see कि heat energy से work done कैसे होगा, work done से heat कैसे होगा and everything. So thermodynamics ऐसा branch है science का जो कि heat energy के exchange की बात करता है, right? Now like in thermodynamics, if we have a system like a system of gas, right, तो उस system का जो state है, right, वो हम define करते हैं using some parameters like pressure, volume, temperature, internal energy, right? So these are your state parameters बच्चों, जो आपके बहुत important होते हैं. Just like your address for आइडेंटिफाइंग यू, हम क्या करते हैं, हम एड्रेस बताते हैं कि ओके दिस इज द फ्लैट नंबर, दिस इज द बिल्डिंग, दिस इज गली नंबर, राइट, दिस इज द एरिया, दिस इज एरिया कोड, और फिर उसके बाद हम बताएंगे कि कौन से सिटी में है और कौन से स्टेट में है एंड देन कौन सी कंट्री में है, राइट. सिमिलरली थर्मोडायनेमिक्स में जब हम एक प्रेजेंट सिस्टम का स्टेट बताना होगा तो हम उसके प्रेशर को देखेंगे, वॉल्यूम, टेम्परेचर और इंटरनल एनर्जी पे फोकस करेंगे, राइट. अप्रोक्सीमेटली बच्चा 2 to 3 क्वेश्चंस, ओके. ऑलराइट, सो लेट्स डिफाइन थर्मोडायनेमिक सिस्टम, है ना, कि अभी तक हम बात करें कि थर्मोडायनेमिक सिस्टम को ऐसे डिफाइन करते हैं, ये उसकी स्टेट्स होती है ना, एवरीथिंग. Now let's understand what is thermodynamic system. So thermodynamic system is nothing but a quantity of matter bounded by some closed surface. Okay. If matter is closed inside a boundary, then this will be your thermodynamic system. Okay. Anything which is outside the thermodynamic system is your what? Surroundings. Anything which is outside the thermodynamic system, outside the boundary, is your surrounding, and system and surrounding can exchange energy with each other, right? So this is your surrounding. The white part is surrounding bachcho, and the black boundary is a separating system from surrounding. Okay, based on the behavior of a system, we define the system in three parts. One is open system, other one is closed system, and third one is isolated system. Open system, that means everything, transfer of each and everything is possible, like transfer of mass is possible, transfer of heat energy is possible, right? So in open system you can transfer mass from the system, you can transfer heat energy from system to surrounding or surrounding to the system, right? In closed system you can transfer mass only, you cannot transfer heat. Fine. So in closed system, a transfer of mass is possible, but transfer of heat is not possible. And third one is isolated system, where you cannot transfer anything. It is isolated from everything, right? You cannot transfer mass, you cannot transfer heat. So transfer of mass and heat is not possible. Fine. I hope this is clear. Any doubt so far? Bacho, any doubt in this one? Sai Vignesh, Casey Reddy, Vaishnavi, Teja, any doubt, Bacho? I hope you guys are making notes, short notes. Don't worry, we will provide everything. यहाँ पे आपको ये PDF मिल जाएगा. But I hope you guys are making notes, right? Any doubt, bacho? No doubt? Okay. Great. So let's move on to the equation of state, right? So we have state parameters, state variables like pressure, volume, temperature. Okay, so we have one equation for, connecting all these parameters, and that is your ideal gas equation. That is PV is equals to nRT, right? P is for pressure, V is for volume, N is number of moles, R is the universal gas constant, and T is your temperature. Any doubt in this one? So you can use equation of state for finding the connection between different state parameters. Okay. Now next is the main important part of this chapter is the thermodynamic process, bachcho. Okay. So let's say we have a thermodynamic system, right? And we have multiple variables associated with this thermodynamic system like pressure, volume, temperature, right? So if you change the state of a thermodynamic system, so its pressure, volume or temperature can change, right? If you are changing the state of a thermodynamic system, pressure, volume, temperature can also change. So this process of changing the state of a system is known as thermodynamic process, right? So we have multiple thermodynamic process, but the most important four processes are isobaric process, isochoric, adiabatic, and isothermal process, right? So isobaric process is that process where pressure is constant. Isobaric process is that process, bachcho, in which the pressure is kept constant. Okay. Apart from pressure, you can change temperature, you can change volume, but you cannot change the pressure, right? So this process is known as isobaric process. Next is isochoric process, also known as isometric process. Okay, so this is that process in which volume remains constant. You can change pressure and temperature, but volume will be constant, right? So this process is isochoric process. Next one is adiabatic process, bachcho. Adiabatic process is the most important one. You'll find most of the questions from this process only in previous year question papers. Okay, so adiabatic process is that process in which you cannot transfer heat. Okay, you cannot transfer heat. Okay, so transfer of heat from system to surrounding or surrounding to system is not permitted, right? So this type of process is known as adiabatic process, bachcho. Next is isothermal process. Isothermal, in which the temperature remains constant, right? Process in which the temperature remains constant. This type of process is known as isothermal process. You can change pressure, you can change volume, but you cannot change the temperature. So most important one is adiabatic, right? So let's understand this processes one by one, but before that we'll have to understand few terms. Okay, so let's start with the thermal equilibrium. Okay, thermal equilibrium, right? Equilibrium, like if you know this term from mechanics, according to you, equilibrium is the condition in which net force and net torque on the body is zero, right? Similarly, we defined equilibrium for the systems. Okay, so thermal equilibrium क्या होता है, right? Let's say we have a two different bodies, right? And if you bring these bodies together, and if there is no transfer of heat, no net flow of heat from one body to another, then these two bodies are said to be in thermal equilibrium, right? आपके पास दो bodies हैं, but on bringing these two bodies closer together, if there is no net flow of heat from one body to another, then the situation is of thermal equilibrium, right? और heat flow कब होता है? When there is some temperature difference, right? When there is some temperature difference. So if temperature difference is not there, there will be no net flow of heat. So in thermal equilibrium, you can say that temperature of one body is equals to temperature of another body, right? Any doubt in this one, guys? Any doubt in thermal equilibrium? Okay, excellent. Next is adiabatic and diathermic wall, bachcho. So adiabatic wall is your insulating wall between two thermodynamic system, which does not allow the flow of energy from one system to another system, right? So adiabatic wall is nothing but the insulating wall जो क्या करेगा, हीट फ्लो को encourage नहीं करेगा, right? Okay, so adiabatic wall is nothing but the insulating wall जो कि allow नहीं करेगा flow of energy from one system to another. So this first one is adiabatic wall. Diathermic wall is your conducting wall which will allow the flow of energy from one system to the another system. This one is your diathermic wall, बच्चों. ठीक है? This is your diathermic wall, right? Next is zeroth law of thermodynamics. Very easy, very important law of thermodynamics, that is zeroth law of thermodynamics. Okay, so let's understand this law. Suppose we have three systems A, B and C, right? Let's say that A and C are connected with a diathermic wall and B and C are connected with a diathermic wall. ठीक है? So initially if there is some pressure temperature difference, तो क्या होगा, AC और B और C सिस्टम के बीच में हीट ट्रांसफर होगा और धीरे धीरे उनका जो टेम्परेचर है वो कांस्टेंट हो जाएगा, सेम हो जाएगा, राइट? सो टेम्परेचर ऑफ A will become equal to temperature of C and temperature of B will be equal to temperature of C. ठीक है, fine. Now you can see that A and B are connected with the wall which is adiabatic wall. Fine. A and B are connected with a wall which is adiabatic wall. Fine. So let's say A and C are in thermal equilibrium with each other. At the same time, B is also in thermal equilibrium with each other. Right? B and C are also in thermal equilibrium. So if temperature of A is equal to temperature of C and temperature of B is equals to temperature of C, then temperature of A should be equal to temperature of B, right? So according to zeroth law of thermodynamics, if two systems A and B are separately in thermal equilibrium with the third system C, then A and B are in thermal equilibrium with each other. ठीक है, A और B भी एक दूसरे के साथ क्या रहेंगे? Thermal equilibrium में रहेंगे. If you remove this adiabatic wall, there will be no net flow of heat from system A to B or from B to A. Right? So this is your zeroth law of thermodynamics. Okay. Next is very important one, bachcho, first law of thermodynamics. Okay. This is very important, bachcho. This one is very important. First law of thermodynamics. ठीक है. तो बच्चों, let me tell you one very important thing, that first law of thermodynamics is based on conservation of energy. किस पे बेस्ड है बच्चों? कंजर्वेशन ऑफ एनर्जी. ठीक है. नाउ if I'm providing you 100 joule of energy, ठीक है, मैं आपको 100 joule of energy दे रही हूँ, ठीक है, तो आपके पास 100 joule of energy आ जाएगी. Okay, you'll get 100 joule of energy. Okay, now let's say out of this 100 joules you are using 40 joules for increasing your internal energy, right? For increasing your internal energy. Okay, so remaining 60 joules is left. Remaining 60 joules is left, बच्चों, है ना? 60 joules जो होगी that will be utilized in the work done. अब यही करोगे बच्चों, पहले अपनी एनर्जी बढ़ाओगे, फिर जो रिमेनिंग एनर्जी होगी उससे क्या करोगे? वर्क डन करोगे, राइट? उससे आप क्या करोगे? वर्क डन करोगे. ओके, फाइन, है ना? So basically यहाँ पे this is the funda of first law of thermodynamics, बच्चों. It states that some quantity of heat is supplied to a system and it is capable of doing some external work, then heat absorbed by the system is equal to the sum of the increase in the internal energy of the system and external work done by the system. राइट, वही है, आपने पहले अपना इंटरनल एनर्जी इंक्रीज किया, देन रिमेनिंग एनर्जी के साथ आपने क्या किया? एक्सटर्नल वर्क किया. ओके, सो लेट्स से यू आर प्रोवाइडिंग डेल्टा क्यू हीट to the system. Delta Q energy, heat is absorbed by the system, delta Q. So this delta Q is divided into two parts. One is increasing the internal energy में, and other one is in doing some external work. So delta Q is equals to delta U plus delta W. Delta Q is the heat provided to the system. Delta U is change in internal energy of the system, and delta W is your external work done. Okay, work done by the system. I hope this is clear. ठीक है, any doubt in the first law of thermodynamics बच्चों? This one is very important बच्चों. ठीक है, okay. All right guys, all right. Excellent. चलो, बहुत ही बढ़िया. So first law of thermodynamics is delta Q is equals to delta U plus delta W, right? So all these three quantities are measured in joules or in calories. Okay, so if you use this equation, make sure that all these three quantities are expressed in the same unit, like either in joules or in calories. ठीक है, ऐसा नहीं होना चाहिए कि one is in joule and other one is in calorie. इससे आपका जो आंसर आएगा that will be wrong. Now next point is very important बच्चों, that delta Q and delta W depend not only on the initial and final states but also on the path of thermodynamic process. Okay, so let's say this is the initial state where the parameter of the state are P1, V1 and T1, and this is the final state where the state parameters are P2, V2 and T2. Right, so delta Q and delta W, that is the heat supplied or heat absorbed or heat released and the work done by the system or work done on the system, depends on the path, the process through which you are changing the state of the system. है ना. If you are changing the state of the system using isothermal process, then delta Q and delta W will be calculated according to the process. If you are changing the state of the system using isobaric process, then delta Q and delta W will be different from that of the isothermal process, right? So for different processes, delta Q and delta W will be different, but delta U depends only on the initial and final states. जो internal energy है, the change in internal energy depends on the initial and final state. If you are, let's say this is your initial state, this is your final state, अगर आप isochoric process से initial से final में जा रहे हो, isobaric से जा रहे हो, adiabatic से जा रहे हो या isothermal से जा रहे हो, तीनों केसेस में, ओके, तीनों केसेस में आपका जो डेल्टा यू होगा दैट विल बी सेम, बिकॉज इनिशियल एंड फाइनल स्टेट इज सेम. आप कौन सा प्रोसेस यूज कर रहे हो दैट डजंट मैटर. Okay, so that is why this delta Q and delta W are your state variables, okay, and this path variables, and this delta U is your state variable, depends on the states only. Okay, work done by the system, gas खुद से expand हो रही है, तो that is work done by the system. If you are compressing the gas, okay, that is work done on the system. If you are doing some work, then this is work done on the system. ठीक है. Now there are some sign conventions that you should follow for first law of thermodynamics. Okay, so we have sign conventions for heat, work and internal energy. So heat supplied is taken as positive. Okay, if you are supplying heat to the system, there is gain in the energy of the system, so take it as positive, right? If heat is extracted, that means heat is removed from the energy, is removed from the system, released by the system, then it is loss in energy बच्चों, so take it as negative. ठीक है. Work done by the system, system खुद से काम करना पसंद करता है, right? So take it as positive बच्चों. Work done by the system is positive. वर्क डन ऑन द सिस्टम, जब आप सिस्टम पे काम करते हो, सिस्टम को ऑर्डर लेना पसंद नहीं है, वो खुद से काम करना पसंद करता है, बट जब कोई और सिस्टम पे काम करे, सिस्टम को अच्छा नहीं लगता, राइट? सो वर्क डन ऑन द सिस्टम इज टेकन एज नेगेटिव. ओके, इंटरनल एनर्जी इज अ फंक्शन ऑफ टेम्परेचर बच्चों, है ना. इंटरनल एनर्जी इज डायरेक्टली प्रोपोर्शनल टू चेंज इन टेम्परेचर. चेंज इन टेम्परेचर इज T final minus T initial. Okay, so if temperature rises, temperature increase होगा, तो T final minus T initial will be greater than 0 and delta T will be positive. Okay, delta T will be positive. Okay, so if temperature rises, then internal energy is taken as positive. If temperature fall मतलब T final minus T initial will be less than 0. Final temperature is less than initial temperature. Then delta T is taken as negative बच्चों, right? So in this case, internal energy will be negative. I hope this is clear. This sign convention is very important बच्चों, very important. Okay, sign convention is very important. One more time. Heat supplied positive, heat released from the system negative, work done by the system positive, work done on the system negative होगा. If temperature increases, internal energy increases. If temperature decreases, internal energy decreases, right? तो ये सारी चीजें बच्चों याद रखनी है. Now based on this, we have one question for you, and most of the questions will be like this only from first law of thermodynamics बच्चों. ठीक है. The question is, in thermodynamic process, 200 joules of heat is given to a gas. Okay, मतलब delta Q is given to a gas, so it is heat supplied to the system, so it is taken as positive. Delta Q is positive, and 100 joules of work is also done on it. Delta W is 100 joules. Now we'll have to decide the sign also. Work is done on it. That means work is done on the system, bachcho. So it is taken as negative, right? Now we need to find the change in internal energy of the gas. What is the change in internal energy of the gas? Come on, guys. I know you can do it. It is based on the first law of thermodynamics. Delta Q is equals to delta U plus delta W, right? Delta Q is given, delta W is given. Oh, very nice, bacho. Very nice, very nice, very nice. Well done, well done, well done. So delta Q is 200, delta U is unknown, and delta W is minus 100. So delta U is equals to 300 joule, which is option B. Okay. So like this, you'll get the questions. Okay. Fine. All right. Now let's study this work in detail. How to calculate work. Each and every line on this slide is very important, bachcho. ठीक है. Work is given by integration of P dV from V initial to V final. Okay, right? Now, look at this one. This is integration process and we have two variables, pressure and volume, right? Okay. Now, let's say if pressure is constant. But so if pressure is constant, you can write work done as P integration dV from V initial to V final. Integration of dV is V. So if you put the limits, it will be P V final minus V initial. So if pressure is constant, you can directly write work done as P into V final minus V initial. And pressure is constant in what process? In isobaric process, right? Okay. So for isobaric process, you can directly calculate the work done using PV final minus V initial. Okay. If pressure is not constant, pressure is variable, like in all the other processes, then you'll have to follow the proper integration method, integration PdV from V initial to V final. Fine. Okay. Now, I'm just simplifying this expression one further. Okay. So for initial state, you can apply PV is equals to nRT, right? So PV initial is equals to nRT initial, right? Similarly, for final state, you can also apply PV is equals to nRT. So for final state, you can write PV final is equals to nRT final. I'm keeping the pressure in both the equations same because I'm talking about this particular case where pressure is constant, right? So instead of PV final, you can write nRT final. So you can write this as nRT final minus, instead of writing PV initial, you can write it as nRT initial. Okay, you can take nR common. Sorry, you can take sorry, nR common. So it will be T final minus T initial. So work done when the pressure is constant is given by P V final minus V initial, or it can also be given by nR T final minus T initial. But the condition is pressure is constant. Okay, right? Now instead of pressure and volume, if PV graph is given. PV graph is also known as indicator diagram. So if indicator diagram is given, then the area bounded by PV graph represents the work done. Area bounded by the PV graph represents the work done. Okay. Again, work done is a path dependent quantity, bachcho. For different processes, work done will be different. Okay. So you'll have different formulas of work done for every process. Okay. But don't worry, I'll make it easier for you. अच्छे से याद हो जाएगा. Right? If volume is constant, that means V final minus V initial should be 0. There is no change in the volume. Okay, so V final minus V initial is equals to 0. So in this case, work done will be integration P dV V final to V initial to V final will be 0. Okay, if there is no change in volume, then the work done is 0. There is no change in the volume, in which case, bachcho, hello Rohit beta. There is no change in the volume, in which case, bachcho, isochoric process, right? Isochoric process में आपका जो work done होगा, that will be 0. Well done, guys. Well done. I hope this is clear. Any doubt in this one? Any doubt so far? Nahi? Great. Now, work done की अगर बात करें तो if volume increases then the work done is positive. If volume is increasing, if gas is expanding, okay, then the work done is positive. Volume increases matlab there's some expansion, right? Well done beta. Okay, there's some expansion of the gas, and in that case work done is positive. If volume decreases, that means you are compressing the gas. Work done by you on the gas is taken as negative, right? तो अब आपको समझ में आया होगा what is the logic behind it बच्चों. If you are doing some work, you are compressing the gas. Okay, if you are compressing the gas, volume decreases and V final will be less than V initial, right? So in that case work done will be negative. If volume increases, work done is positive. Volume decreases, work done is taken as negative. Now we have one more type of process, that is cyclic and non-cyclic process. तो समझाऊंगी मैं, आगे आएगा. But remember, cyclic process में work done is positive if the cycle in PV graph is clockwise. For clockwise cycle, we take work done as positive, and for anti-clockwise cycle, we take work done as negative. Let me show you how. Okay, yes. Okay, so see, look at this one. This is PV graph. Okay, this is the first graph. This is the initial state 1. This is the final state 2. This is the initial volume V1, and this is the final volume V2. So this is your expansion. If you look at this one, this is expansion of the gas. Gas is expanding, that means work done is positive. So area under this complete graph will be equal to work done, and work done will be greater than 0, right? It is positive. In the second case, look at this one. This is the initial state बच्चों. Look at the arrow. हमेशा arrow को ध्यान देना. This is the second state. Okay, so this is initial state. This is final state. Initial volume is V1 and final volume is V2, but V2 is less than V1. Okay, so यहाँ पे compression हो रहा है. In the second case, this is your compression. Okay, so it will be this work done, but this work done will be less than 0. Work done will be negative, right? Now in this case, you can see that pressure is not constant. Pressure is changing, है ना? So that is why in order to find the work done in both the cases, you'll have to use this PdV integration V1 to V2 is equals to work done. If pressure is not constant, then you'll have to use the integration process. Okay. Now in the third case, it is just an expansion from state 1 to 2, but the pressure is kept constant. So you can directly find work done as P into V2 minus V1, and this work done will be positive because gas is expanding. Okay. चलिए बहुत बढ़िया, बहुत ही बढ़िया. Well done guys. Now when we talk about the cyclic process, it is very easy. देखो, initial state is A, then next state is B, then next state is C, then next state is D, and finally the gas is again at its initial state. मतलब initial state is equal to final state. The process is known as cyclic process. ठीक है? Now cyclic process, this is your clockwise cyclic process. For clockwise cyclic process, बच्चों work done is equal to area of this graph. Okay, so area of this rectangle is equals to work done, and it will be positive because it is a clockwise cycle. Okay, similarly in the second case, you can see that it will be like this. Arrow थोड़ा सा उल्टा हो गया इसका. Okay, this is your anti-clockwise cycle, right? For anti-clockwise cycle, work done is taken as negative, and area will be equal to area of this rectangle, which is equals to work done. Any doubt in this one बच्चों? Any doubt in this one? Work done वाला जो process है, it is very important बच्चों. ठीक है? Especially the cyclic process में, how to find the work done is very important. Okay, very important. चलिए, बहुत बढ़िया, बहुत ही बढ़िया. Okay, now let's do one question based on this cyclic process. An ideal monoatomic gas is taken around the cycle as shown in PV diagram. The work done during the cycle is, what is the work done during the cycle? So this is the ABCD states, है ना? V naught, 2 V naught, P naught, 2 V naught is given. We need to find the work done in this cyclic process. So work done is equals to area of this rectangle, and this is your clockwise cycle. So yes, PV, well done Rohit, well done. PV, right? So this is your clockwise cycle. Yes, Sai Vignesh, बहुत बढ़िया बेटा. So work done will be positive. कितना होगा बच्चों? It is length into width. Length कितना है? V naught to 2 V naught. So it is just V naught. Width is from P naught to P naught. So it is P naught, right? So P naught V naught is the work done. That is positive. Yes, बच्चों. Option B is correct. Well done, बच्चों. Okay. Now next is internal energy of a thermodynamic system. Okay. So like in first law of thermodynamics, we use three things. One is internal energy, other one is work done, and third one is heat. Okay. So work done आपको समझ में आ गया कैसे निकालना है? Integration P dV. If pressure is constant, it is just P delta V. If PV diagram is given, so area under PV diagram is your work done, right? Okay, now let's talk about the second parameter which is involved in the first law of thermodynamics, that is internal energy of a thermodynamic system. Okay, so internal energy is nothing but the total energy possessed by the system due to molecular motion and molecular configuration. ओके मॉलिक्यूल्स मोशन करेंगे तो उनके मोशन के कारण जो इंटरनल एनर्जी आती है, दैट इंटरनल एनर्जी इज नोन एज internal kinetic energy. Okay, internal kinetic energy, UK. Fine. Similarly, because of the attraction between the molecules, because of the interaction of the molecules with each other, we have one more energy, that is internal potential energy. Okay, so total internal energy of any system is nothing but the summation of internal kinetic energy and internal potential energy. UK plus UP is your total internal energy. Fine. Internal energy is a state variable. That means it depends on the initial and final state. It does not depend on the path taken to arrive at that state. राइट इंटरनल एनर्जी में ये फर्क नहीं पड़ता कि यू आर यूजिंग आइसोकोरिक प्रोसेस, आइसोबैरिक प्रोसेस, आइसोथर्मल प्रोसेस, कोई फर्क नहीं पड़ता. फाइन, ठीक है. The formula will be same for all the processes. I hope this is clear, right? Next is internal energy is like अगर आप KTG में पढ़ते हो तो इंटरनल एनर्जी एक आइडियल गैस की बात करूं मैं. सो इन आइडियल गैस वी अज्यूम्ड दैट द मॉलिक्यूलर अट्रैक्शन इज जीरो, है ना. इफ मॉलिक्यूलर अट्रैक्शन इज जीरो, दैट मीन्स पोटेंशियल एनर्जी ऑफ द मॉलिक्यूल्स इज जीरो, है ना. सो इंटरनल एनर्जी में जो U पोटेंशियल होता है, इंटरनल पोटेंशियल एनर्जी फॉर एन आइडियल गैस इज टेकन एज जीरो. ठीक है, तो फिर if U is equals to UK plus UP and if UP is 0, that means entire internal energy of the system is in the form of kinetic energy of the molecules. और वो कैसी होती है? 3/2 nRT. 3/2 nRT बच्चों. N is the number of moles, R is the universal gas constant and T is the temperature. Okay, fine. Now change in internal energy is nothing but 3/2 nR delta T. Okay, 3/2 nR delta T. It is also defined as NCV delta T. CV is your specific heat capacity at constant volume. अभी सब आएगा, don't worry, everything is in there. ठीक है. CV is F/2 R. Okay, CV is F/2R. So instead of CV, you can write it as F/2 nR delta T. And CV is also R upon gamma minus 1. So you can write it as nR upon gamma minus 1 into delta T. So do remember all these expressions of change in internal energy of a system. 3/2 nRT, NCV delta T, F/2 nR delta T, and nR upon gamma minus 1 delta T. Don't worry, I'll cover everything. What is F, what is gamma, what is CV. ठीक है, अब धीरे धीरे सब कुछ आएगा, right? Next is heat in thermodynamics. So heat is nothing but the energy which is being transferred from one system to another because of the temperature difference. Okay, now look at this two system. One is blue system, other one is purple system, and you can see that the flow of energy is from T1 to T2. Why T1 to T2? Because the T1 and T2 temperatures are different from each other, and heat transfer takes place from higher temperature to lower temperature, right? So T1 is greater than T2. That is why heat जो transfer हो रहा है, that is from higher temperature to lower temperature, and heat is path dependent quantity, and it is given as Q is equals to NC delta T, where N is the number of moles, C is the specific heat, and delta T is the चेंज इन टेम्परेचर. अभी आपको मैं दिखाऊंगी कि कैसे ये पाथ डिपेंडेंट है. स्पेसिफिक हीट कैपेसिटी of a gas of a system depends on the process. For different processes, specific heat capacity will be different. कैसे समझते हैं? चलो. So let's start with the specific heat. Specific heat को हम दो पार्ट में डिवाइड करते हैं. One is gram specific heat and other one is molar specific heat. Okay. So it is nothing but बच्चों, let's say I have 1 gram of a substance. Okay. Right? I have a 1 gram of a substance. Okay. And I want to raise the temperature of this 1 gram by 1 unit. Okay, then the heat given to the substance in order to raise the temperature by 1 unit is known as gram specific heat. It is denoted by capital C and it is heat divided by mass into delta T. So it is joule per kilogram Kelvin is the unit, SI unit of this gram specific heat, but we are more interested in molar specific heat बच्चों. ठीक है. So let's say instead of 1 gram we have 1 mole of a substance and I want to raise the temperature of this 1 mole of a substance by 1 unit. Then the heat required to raise the temperature of a 1 mole of a substance by 1 unit is nothing but molar specific heat capacity, right? And it is Q upon N delta T. Q is heat given, N is number of moles, and delta T is the change in temperature. So it is joule per mole into Kelvin. So this is the SI unit of this molar specific heat capacity. I hope this is clear, right? So let's understand few cases of molar specific heat capacity, right? Let's say a gas is suddenly compressed. Okay, let's say a gas is suddenly compressed and no heat is supplied from outside. Okay, but the temperature of gas rises on account of compression. If you compress the gas, its temperature increases. बट यू आर कंप्रेसिंग इट सडनली, एकदम से कंप्रेस कर दिया तो हीट को बाहर जाने का टाइम नहीं मिला, तो उस केस में Q विल बी जीरो, बट Q is also NC delta T. If Q is zero, N cannot be zero, temperature change cannot be zero, then C should be zero, right? So if there is no heat exchange, then the specific heat capacity is taken as zero. राइट. सो देखो सी आपका जो है दैट इज केस डिपेंडेंट. आप क्या कर रहे हो सिस्टम के साथ, ओके, व्हाट प्रोसेस यू आर फॉलोइंग इन ऑर्डर टू चेंज द स्टेट ऑफ द सिस्टम, उस पर डिपेंड करेगा कि आपका सी का वैल्यू क्या आएगा. फाइन. If the gas is heated and allowed to expand at such a rate that rise in temperature due to heat supplied is exactly equal to fall in temperature due to the expansion of the gas. आपने heat supply किया, temperature increase हुआ, but at the same time because of the expansion of the gas temperature down हो गया. Let's say जितना temperature increase हुआ उतना ही temperature down हो गया, तो net change in temperature becomes zero and C is equals to Q upon N delta T. If delta T is zero, which is in denominator, so Q upon zero will become what? Infinite, right? So if there is no change in the temperature of the system, specific heat capacity is taken as infinite. कौन से process में temperature change नहीं होता बच्चों? Isothermal process. Okay, isothermal process. Okay, कौन से प्रोसेस में आपका हीट एक्सचेंज नहीं होता इन एडियाबैटिक प्रोसेस, राइट? सो इन एडियाबैटिक प्रोसेस you can take the value of C as 0, and in isothermal process you can take the value of C as infinite, right? Now let's say you are following certain processes जहाँ पे delta T is positive, मतलब net, yes बच्चों, very nice, very nice, net increase in temperature is positive, then the specific heat capacity will be positive. If net increase in temperature, sorry, net temperature is negative, net change in temperature is negative, then C is taken as negative, right? So your specific heat capacity can be positive, can be negative, it can be zero, it can be infinite, depends कि आप कौन सा process use कर रहे हो, right? And we have this term involved in heat in thermodynamics, ठीक है? Heat is NC delta T. For different processes, C is different. So that is why आपका जो heat है, that is nothing but a path function, मतलब process dependent function है, ठीक है? चलिए, बहुत बढ़िया guys, बहुत ही बढ़िया. Right, now let's see what is specific heat capacity for constant volume and for constant pressure. So for constant volume, we define specific heat capacity as Cv, that is specific heat capacity at constant volume. This will be used for isochoric process. Constant volume मतलब isochoric process. Okay. So Cv is nothing but the amount of heat required to raise the temperature of 1 mole of gas by 1 degree Celsius. Okay. At constant volume. If the volume of the system is constant and you are increasing the temperature of 1 mole of gas by 1 degree Celsius, then the heat required is nothing but the molar specific heat capacity at constant volume. It is denoted by Cv and it is given as F by 2R or R upon gamma minus 1, where F is degree of freedom. Okay. F is degree of freedom and gamma is adiabatic constant. So for monoatomic gas, degree of freedom is equal to 3. So यहाँ पे you can write it as 3 by 2R. For diatomic and triatomic linear gas, degree of freedom is given as 5. So the value of Cv is 5 upon 2R. For polyatomic nonlinear gas like triatomic nonlinear gas, degree of freedom is 6. Okay, so for this one, 6 upon 2R will be 3R. So these are the values of Cv for different types of gases: monoatomic, diatomic, triatomic, linear gas and polyatomic non-linear gas. I hope this is clear, bachcho. Any doubt in this one? Any doubt? Okay. Next is specific heat capacity of gases at constant pressure. Okay, so it is denoted by Cp. Let's say we have a system jiska, yes, gamma, I'll come to the gamma, don't worry. Jiska pressure is constant. We are keeping pressure as constant. That means we are talking about the isobaric process. Okay, so for isobaric process, if you increase the temperature of 1 mole of gas by 1 degree Celsius, then the heat required is equal to molar heat capacity of the gas at constant pressure. It is given as 1 plus F by 2 R, or it is gamma R upon gamma minus 1. You can derive this relation using the Mayer's formula Cp minus Cv is equals to R. Okay. For monoatomic gas, it will be degree of freedom for monoatomic is 3. So it is 1 plus 3 by 2 into R, which is 5 by 2R. Okay. I'll come to the gamma beta, don't worry. Diatomic, triatomic linear gas, degree of freedom is 5. So it is 1 plus 5 by 2R, which is 7 by 2R. And for polyatomic non-linear, degree of freedom is 6, right? So it is 1 plus 6 by 2, which is 4 into R. So 4R is the value of Cp for all these gases. I hope this is clear. Try to remember everything as it is, bachcho. Fine. So gamma is nothing but the adiabatic constant. It is nothing but the ratio of Cp to Cv, bachcho. Cp upon Cv is a new term, that is gamma, that is your adiabatic constant, and it is given by 1 plus 2 upon F. Okay. So for monoatomic gas, it will be 1 plus 2 by 3, which is 5 by 3, which is approximately 1.67. For diatomic gas, it will be 1 plus 2 by 5, which is 7 by 5, which is 1.4. And for polyatomic non-linear gas, it will be 1 plus 6 by 5. Okay, 1 plus, sorry, 2 by 6. It is 1 plus 2 by F, right? So it is 1 plus 2 by 6, 1 plus 1 by 3, that is 4 by 3, which is 1.33. So these are the values of gamma for monoatomic, diatomic or triatomic linear, and this is for polyatomic non-linear. Any doubt in this one, guys? Any doubt? Okay, this will be used in the adiabatic process. एडियाबेटिक प्रोसेस में हम इस टर्म को बहुत अच्छे से यूज करेंगे एवरीवन. ओके, सो इट इज Cp upon Cv or it is 1 plus 2 by F. This is known as adiabatic constant. Any doubt बच्चों? Any doubt in this one? Okay, great, excellent. चलिए, so now let's talk about the gaseous mixture. बच्चों, ये जो formulas हैं, ये as it is आपके एग्जाम में पूछे जाते हैं. Let's say I have two gases. First is, let's say, gas 1 and other one is gas 2. Okay. Let's say gas 1 के number of moles है N1. For gas 2, number of moles are N2. Molar mass is M1. Molar mass is M2. Specific heat capacity of gas 1 at constant volume is Cv1, and specific heat capacity of gas 2 at constant volume is Cv2, and specific heat capacity of gas 1 at constant pressure is Cp1, and this is Cp2. ठीक है? So what you can do is, when you mix these two gases, you can find equivalent value of Cv, equivalent value of Cp, equivalent molar mass and equivalent value of gamma. Okay, let's say iska adiabatic constant is gamma 1 and iska gamma 2. So Cv mixture is given by N1 Cv1 plus N2 Cv2 divided by N1 plus M2. In the question, Cv1, Cv2, N1, N2 will be directly given to you. You can directly apply this expression for finding the Cv of mixture. ठीक है? Similarly, Cp of mixture will be N1 Cp1 plus N2 Cp2 divided by N1 plus N2. Right? Similarly, molar mass of the mixture. This is for mixture. Okay. Molar mass of the combined mixture will be N1 M1 plus N2 M2 divided by N1 plus N2. And similarly, gamma of the mixture. This gamma is for mixture. It is given as N1 plus N2 divided by gamma minus 1 is equals to N1 upon gamma 1 minus 1 plus N2 upon gamma 2 minus 1. Okay, so try to remember this expressions bachcho as it is, and I hope you are maintaining everything in your notes right now. ठीक है? Because thermodynamics से जो questions आते हैं, all this most of these questions are from theory only. आपसे सीधा सीधा definition का एक part उठा के options में पूछ लिया जाता है. So if you can maintain everything in a notebook, it will be easier for you and you can directly answer 2 to 3 questions from this chapter, जिसका weightage होता है approximately 9%, right? Now let's start with the processes बच्चों, है ना? Processes में yes, well done beta. Processes में everything is important, every line is important बच्चों, ठीक है? So this is your isobaric process. Isobaric process is that process in which system undergoes a physical change but pressure remains constant. Okay, so this is your isobaric process. What is the equation of state? Like if you want to compare state 1 with the state 2, then how to compare this state 1 with state 2? For that we have equation of state. Let's say this is the state 1, initial state, and this is the final state 2. Okay, so state 1 में जो parameters है, pressure is P, volume is V1, temperature is T1. At the same time, state 2 के जो parameters है, that is P, V2 and T2. मैम pressure तो PP रखा, Bachcho, pressure is constant. That is why I'm keeping pressure P and P for both state 1 and state 2. Right. Now you can apply PV is equals to nRT, bachcho. Now N is constant, R is constant, pressure is constant. So you can see that volume is directly proportional to temperature. Okay. Volume is directly proportional to temperature. You can write V upon T is equals to nR upon P. nR upon P is a constant term. है ना? So for both the state, nR upon P will be equal. So you can write V1 upon T1 is actually equal to V2 upon T2. So this is your equation of state बच्चों कि V upon T is constant, or if you want to compare two states with each other, V1 upon T1 is equals to V2 upon T2. Now if you draw pressure versus volume graph, it is your indicator diagram, है ना? And it is very simple बच्चों. Pressure is kept constant. You are changing the volume. तो देखो, this is initial volume, this is final volume. यहां से यहां तक आपको क्या मिलेगा? Straight line. Why? Because pressure is constant. So this is isobaric compression. You are compressing the gas. In this case, this is initial volume, this is final volume. So this will be your indicator diagram. Arrow is very important, bachcho. This is showing isobaric expansion. In this will be the total work done, but the work done will be negative, right? And in this will be the total work done, but work done will be positive, because यहाँ पे expansion होता है, यहाँ पे क्या होता है? Compression होता है. Remember this thing we did in work done, right? तो ये सारी चीजें अब यहाँ पे आप अप्लाई करोगे. हीट, इंटरनल एनर्जी, वर्क डन, सारी चीजें आप यहाँ पे बच्चों क्या करोगे? अप्लाई करोगे. नेक्स्ट इज आइसोबैरिक प्रोसेस का वर्क डन. सो इट इज वेरी सिंपल. जो अभी हमने किया था इन वर्क डन बच्चों, इट इज P V final minus V initial, or it is nR T final minus T initial. Okay. How to write first law of thermodynamics for the isobaric process? It is very simple. What is the first law of thermodynamics? That is delta Q is equals to delta U plus delta W. Delta Q is the heat supplied or heat released from the system. Delta U is the internal energy, and delta W is nRT final minus T initial. ठीक है, fine. So that is how you can write first law of thermodynamics for isobaric process. ठीक है. Do not mug up this one. If you know what is work done in isobaric process, you can put the value of work done over here directly. ठीक है. Yes बच्चों, yes रोहित, very nice बेटा, very nice. ठीक है. चलो, next is isochoric process. So thermodynamic process occurring at constant volume is known as isochoric process. है ना? Volume is kept constant, pressure temperature change हो सकता है, right? So PV is equals to nRT में बच्चों, N constant, R constant, V constant. तो P upon T will be nR upon V, which is constant. So this is the state of equation. P upon T is equals to constant. If for state 1 parameters are P1 V T1, and for state 2 parameters are P2 V T2, then you can write P1 upon T1 is equals to P2 upon T2. That is how you can compare these two states. ठीक है. ग्राफ इज वेरी सिंपल बच्चों. वॉल्यूम कांस्टेंट है. एक और चीज बताना चाहूंगी बच्चों. यहाँ पे look at this one. This is a straight line. In this one, like in this one, if you draw a graph, pressure versus volume. So pressure versus volume का जो graph है, that is straight line parallel to volume axis. What is its slope? Slope is given by delta P divided by delta V. Change in Y divided by change in X. Okay, but change in Y is 0. Pressure is constant, so change in Y is 0. That is why slope of this PV graph is 0. ठीक है? Slope of this PV graph is 0. Fine. I hope this is clear, right? Similarly, in this one, let's talk about the graph first, then we'll talk about the slope. Okay. So for this one, let's say this is the volume V of the system. Pressure आप increase कर रहे हो from P initial to P final. Okay, so volume will remain constant, so graph will be a straight line parallel to pressure axis. Okay, fine. Yes, Angrela, hello, clear, very nice beta. Chalo. Okay, so basically in this case, if you look at the slope is nothing but the angle made by this line with the x-axis. 90 degree इसका tan theta. So tan 90 degree is infinite. So slope of this one is infinite. Slope is also given as delta p upon delta v. But delta v is 0. Net change in volume is 0. So delta p upon 0 is infinite. ठीक है? Fine. So basically for this one, for isochoric process, the slope of PV diagram is taken as infinite. है ना? चलिए बहुत बढ़िया गाइस. नाउ लुक एट दिस वन. अगर मैं पीवी डायग्राम के नीचे का एरिया पता करूं, सो देयर इज नो एरिया, दिस इज जस्ट अ लाइन. इसके नीचे का अंडर का एरिया विल बी 0, राइट? सो वर्क डन विल बी 0 इन आइसोकोरिक प्रोसेस. ठीक है, फाइन. Yes, well done. Similarly, if you are decreasing the pressure, यहाँ से यहाँ आपका ग्राफ बनेगा, एरो head जो है वो उल्टा हो जाएगा. You'll have to just reverse the arrow head. Fine. Otherwise, everything is same. So this is your PV diagram for isochoric process. ठीक है. Work done is P delta V बच्चों, which is 0. Why? Because delta V is equals to 0. So you can write first law of thermodynamics as, देखो यहाँ से बहुत प्यारी प्यारी क्लैरिटी मिलेगी आपको. First law of thermodynamics, that is delta Q is equals to delta U plus delta W. But delta U is equals to 0. So delta Q is equals to delta U. So in isochoric process, आपका जो system है वो बहुत greedy बन जाता है, बहुत लालची बन जाता है. वो क्या करता है कि आपने जितना heat supply किया system को, वो पूरा की पूरा heat system अपनी internal energy change करने में लगा देता है. Okay, if internal energy of the system is decreasing in isochoric process, then that decrease in internal energy will be released in the form of heat. उसका just उल्टा statement. If you are supplying some heat to the system, internal energy of the system will increase, and the increase in internal energy will be equal to heat supplied. But अगर आप internal energy of the system is decreasing, right, then पूरा की पूरा decrease in internal energy will be released in the form of heat. Fine, I hope this is clear. ठीक है. And we know that आपका जो delta Q होता है, that is NCV delta T, so it will be delta U is NCV delta T, so it will be delta Q is equals to delta U, which is equals to NCV delta T. Fine. चलिए बहुत ही बढ़िया. Next is isothermal process. So process occurring at constant temperature is your isothermal process बच्चों. What is equation of state बच्चों? PV is equals to nRT. nR is constant, T is constant, that means PV is equals to constant, right? So if initial state is P1 V1T and final state is P2 V2T, then you can write P1 V1 is equals to P2 V2. This is your equation of state. Okay. Again बच्चों, there is no change in temperature. जैसा कि आपको बताया था, specific and molar heat capacities are infinite, right? But the work done is not 0, and it is given by nRT ln V final upon V initial, or it is nRT ln P initial upon P final. Okay, you can write यहाँ से V2 upon V1 को you can write P1 upon P2, है ना? So यहाँ से वही replace किया using the equation of state बच्चों. Hello Jack, good afternoon बेटा. ठीक है. और if like ln is log base e, if you write this thing in terms of log base 10, you can write it as 2.303 nRT log base 10 V final upon V initial, right? So this is the work done in isothermal process. देखो work done in all the processes is different. For isobaric process it is P delta V. In isochoric process it is 0. In isothermal process it is equal to nRT ln V final upon V initial. So work done is what? Your path dependent quantity, right? देखो prove होता है everything is interconnected बच्चों. ठीक है. So this is your work done. Now let's talk about the graph of isothermal process, right? So basically PV is equals to constant. Okay, so P is inversely proportional to V, and for inverse relation we use hyperbola, है ना? So PV diagram of isothermal process is hyperbolic. Okay, तो यहां से दो चीजें हो सकती हैं. अगर आप प्रेशर जो है, see, P is inversely proportional to volume. If you are increasing the volume, pressure will decrease. ठीक है. If you are no Rohit Sharma, it is V final upon V initial, no. Okay, if you are decreasing the pressure, volume will increase. और आप उल्टा बोल सकते हो कि अगर आप प्रेशर इंक्रीज करोगे तो वॉल्यूम डिक्रीज होगा. तो देखो यहाँ पे यू आर इंक्रीजिंग द वॉल्यूम फ्रॉम वी इनिशियल टू वी फाइनल, तो प्रेशर आपका पी इनिशियल टू पी फाइनल क्या होगा, डिक्रीज होगा, राइट. एंड दिस वन वी विल बी योर हाइपरबोलिक ग्राफ लाइक दिस, नॉन लीनियर ग्राफ लाइक दिस. ठीक है, फाइन. सो दिस इज योर आइसोथर्मल एक्सपेंशन. आइसोथर्मल एक्सपेंशन में बच्चों क्या हो जाएगा, प्रेशर आपका डिक्रीज हो जाएगा. नाउ उसका जस्ट उल्टा, लेट्स डिक्रीज द वॉल्यूम. नाउ वी इनिशियल टू वी फाइनल, वॉल्यूम डिक्रीज कर रहे हैं, वॉल्यूम डिक्रीज करेंगे तो प्रेशर क्या हो जाएगा, इंक्रीज हो जाएगा, राइट. सो आपका प्रेशर पी इनिशियल टू पी फाइनल हो जाएगा, एंड दिस विल बी योर ग्राफ from this to this, right. So this is your isothermal compression. Okay, now how to find the slope of this PV graph. तो इसका slope find करने के लिए what we do is we just choose a point. Point पे हम जाके एक tangent draw करते हैं. इस tangent ने जो angle बनाया उसका tan theta will be the slope, है ना. But we can't do it, है ना. Every time we can't measure the angle and everything, so we have a definite value of slope, that is minus p by v. So slope of PV diagram is minus p upon v. ठीक है, slope of PV diagram is minus p upon v. If you know the value of pressure at this point and value of volume at this point, you can find the slope of this point. Okay, so slope of PV diagram in isothermal process is minus p upon v. Very important बच्चों, very important, सीधा सीधा आ जाता है. Fine, चलिए बहुत ही बढ़िया. Now how to write first law of thermodynamics for isothermal process. So it is very simple बच्चों. Delta Q is equals to delta U plus delta W, है ना. Delta U is your what, state function, and it is your NC delta T, है ना, NCV delta T. But change in temperature is zero. Change in temperature is zero in isothermal process, so delta T will be zero, है ना. Delta T will be zero. If delta T is zero, that means delta U will be zero. If temperature is constant, यहाँ से बच्चों आप याद रख सकते हैं, if temperature is constant, internal energy of the system is constant. That means there will be no change in internal energy of the system. That means delta Q is equal to delta W, and that is nRT ln V final upon V initial, right. और यहाँ से बच्चों एक और चीज क्लियर होती है कि if you are supplying any heat to the system or in isothermal process में complete heat आपने जो supply किया, that will be utilized in doing some work. Okay, unlike your कौन सा system था ये, जहां पे isochoric process में आप हीट सप्लाई करते थे, सिस्टम अपने पास इंटरनल एनर्जी की फॉर्म में रख लेता था. बट अनलाइक आइसोकोरिक प्रोसेस, आइसोथर्मल प्रोसेस इज सेल्फलेस प्रोसेस. वो अपने पास कुछ नहीं रखेगा, वो बोलेगा मुझे अपनी इंटरनल एनर्जी चेंज नहीं करनी, मैं जितना हीट आप दोगे एंटायर हीट विल बी यूज्ड इन डूइंग सम वर्क. ओके फाइन. या फिर आप सिस्टम पे अगर कुछ वर्क करते हो तो पूरा की पूरा वर्क डन इन द फॉर्म ऑफ हीट रिलीज हो जाएगा, which is equals to nRT ln V final upon V initial. Any doubt in this one, guys? Any doubt in isothermal process? Nahi? Great. Next is adiabatic process, which is very important बच्चों. Adiabatic process is very important. Okay, ठीक है. So adiabatic process is that process in which there is no transfer of heat into or out of the system. ना तो हीट सिस्टम से बाहर जाएगी ना सिस्टम के अंदर आएगी फ्रॉम द सराउंडिंग, राइट? सो दिस प्रोसेस इज एडियाबैटिक प्रोसेस विच इज वेरी इंपॉर्टेंट. Now we have equation of state for adiabatic process. So we have PV power gamma is equals to constant. आपको पता है एक मजेदार बात बताऊं एडियाबेटिक प्रोसेस का, ये तीनों इक्वेशन 3 बार पूछी गई है. फर्स्ट टाइम ये पूछा गया, देन ये एंड देन ये. इन नीट एग्जाम ये तीनों इक्वेशंस को इन द फॉर्म ऑफ क्वेश्चन पूछा गया कि व्हाट इज द इक्वेशन ऑफ स्टेट ऑफ एन एडियाबेटिक प्रोसेस. एक बार ऑप्शन में ये था, एक बार ऑप्शन में ये था और एक बार ऑप्शन में ये था, right? So you should remember the state equation of state for adiabatic process, right? PV power gamma is equals to constant. Now we know that PV is equals to nRT. So you can write pressure as nRT upon V in this equation. So it will be nRT upon V into V power gamma is equals to some constant. ठीक है, so it is T into V power gamma minus 1 is equals to constant upon nr. Constant upon nr is also another constant. So TV power gamma minus 1 is constant. Similarly, if you replace the value of the volume as nRT upon P, you will get this equation, that is T power gamma into P power 1 minus gamma is equals to constant. ये तीनों इक्वेशन सेम है, बस PV is equals to nRT से बार बार इनको क्या करा जा रहा है, मैनिपुलेट करा जा रहा है, राइट? So thermodynamic process जहाँ पे heat transfer is not possible, that is your adiabatic process. Equation of state is PV power gamma is equals to constant, या फिर TV power gamma minus 1 is equals to constant, या फिर T power gamma P power 1 minus gamma is equals to constant. Okay, the graph of adiabatic process is almost similar to that of the isothermal process, PV diagram, right? Okay, so in this case you can see that if you are increasing the volume, pressure is decreasing, but this graph is like according to the equation PV power gamma is equals to constant. This is same as that of the isothermal, the only difference is of slope. Okay, slope of PV diagram in adiabatic process is minus gamma times P upon V, right? Isothermal process में जो slope था बच्चों, that was minus P upon V. For adiabatic it is minus gamma times P upon V. So अगर मैं magnitude की बात करूँ तो slope of adiabatic process is more because gamma is always greater than 1. देखो गामा आपका हमेशा greater than 1 है for all the gases. देखो यहाँ पे 1.67, 1.4, 1.33. Okay, yes, Sai, Vignesh, they'll ask directly. I'll tell you one question from NEET exam, recent one, and you'll get to know कि कैसे questions आते हैं, ठीक है? So, see, gamma is always greater than 1, right? So, slope of adiabatic process is more as compared to isothermal process magnitude wise. So adiabatic curves are more steeper as compared to the isothermal curve. If you draw isothermal and adiabatic side by side, तो नीचे वाला जो steeper curve है that is for adiabatic process and less steeper will be of isothermal process. Similarly, if you increase the value of gamma, आपका देखो gamma for यहाँ पे अगर आप देखोगे तो गामा फॉर अरे सॉरी हम फॉरवर्ड जा रहे हैं, हमें बैकवर्ड जाना है, ठीक है? गामा फॉर मोनोएटॉमिक इज 1.67 विच इज मोर एज कंपेयर टू डायटोमिक एंड ट्राइटोमिक, ठीक है? तो गामा जितना ज्यादा होगा उसका कर्व ज्यादा स्टीप होगा. सो इफ यू कंपेयर फॉर मोनोएटॉमिक, डायटोमिक एंड ट्राइटोमिक, सो मोनोएटॉमिक का कर्व विल बी मोर स्टीपर एज कंपेयर टू डायटोमिक एज कंपेयर टू ट्राइटोमिक बिकॉज गामा ऑफ मोनोएटॉमिक इज मोर एज कंपेयर टू गामा ऑफ डायटोमिक एज कंपेयर टू गामा ऑफ ट्राइटोमिक, ठीक है? फाइन. All right, specific heat capacity of adiabatic process will be 0. Why? Because delta Q is equals to NC delta T. Delta Q is 0. That means आपका N नहीं 0 हो सकता, delta T नहीं 0 हो सकता, तो C will be 0. Work done in adiabatic process is P1 V1 minus P2 V2 divided by gamma minus 1, or it is NR upon gamma minus 1 T1 minus T2. ठीक है। फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स बच्चों कैसे लिखोगे, डेल्टा क्यू इज इक्वल्स टू डेल्टा यू प्लस डेल्टा डब्ल्यू, राइट। तो यहाँ पे डेल्टा क्यू इज जीरो, सो डेल्टा यू प्लस डेल्टा डब्ल्यू शुड बी जीरो, सो डेल्टा यू विल बी माइनस डेल्टा डब्ल्यू, right? So basically work is done on the expense of internal energy. In adiabatic process, if you want to do some work, you'll have to utilize your internal energy. ठीक है, fine. So this is the first law of thermodynamics for adiabatic process, right? Now let's come to the cyclic process. So a process or series of processes in जिसमें after certain interchanges of heat and work the system is restored to its initial state, है ना। सिस्टम ने यहाँ A से अपना स्टेट स्टार्ट किया, D to C गया, फिर वापस C to B to A आ गया. So in this case initial state is equals to final state after the certain processes. Fine. So this type of processes are your cyclic processes. Fine. इन साइक्लिक प्रोसेसेस इनिशियल स्टेट और फाइनल स्टेट क्या हो जाते हैं बच्चों, इक्वल हो जाते हैं, मतलब इनिशियल टेम्परेचर और फाइनल टेम्परेचर भी इक्वल हो जाएगा. सो इन दिस केस डेल्टा यू दैट इज द चेंज इन इंटरनल एनर्जी विच डिपेंड्स ऑन द चेंज इन टेम्परेचर. डेल्टा टी आपका जीरो हो जाने की वजह से इंटरनल एनर्जी में चेंज क्या हो जाएगा, जीरो हो जाएगा. For cyclic process, you can write first law of thermodynamics as delta Q is equals to delta W, because delta U will be 0, right? So we have one question for you बच्चों, from 2017. Vignesh, you were asking कि कैसे question आते, तो बेटा देखो ये question है आपका. Thermodynamic processes are indicated in the following diagram. First one is like this, PV diagram में. Second one is like this is first, this is second. Third one is like this and fourth one is like this. आपको बताना है कि ये कौन कौन से ग्राफ्स हैं, like first belongs to which process, second belongs to which process, third and fourth and so on, right? So try this one बच्चों, try this one. Try this one guys. क्या आएगा? Okay, first one is for isochoric process. Very nice. First one is for isochoric process. Fourth भी easy है. Fourth भी easy है बच्चों. This is for isobaric. Pressure is constant. No. Now लड़ाई जो है that is between second and third only, है ना. Second जो है that is what? हाइपरबोलिक. थर्ड भी आपका हाइपरबोलिक नेचर शो कर रहा है, बट वी नो दैट इन एक्सपेंशन अगर हम बात करें एडियाबैटिक और आइसोथर्मल की, तो एडियाबैटिक कर्व्स आर मोर स्टीपर एज कंपेयर टू द आइसोथर्मल. व्हिच वन इज मोर स्टीपर बच्चों? दिस वन. सो सेकंड वन विल बी फॉर एडियाबैटिक एंड द रिमेनिंग वन विल बी फॉर आइसोथर्मल. ठीक है, रिमेनिंग वन विल बी फॉर आइसोथर्मल, राइट. तो यहां से बच्चों you can compare process 1 is for isochoric which is option C, then second one is for adiabatic which is option A, yes, then third one is for isothermal option D, and fourth one is for isobaric option B, right? So it is C A B D with D B, which is option A. Well done guys, well done. I hope this is clear, है ना. ठीक है. Now next is heat engine. Okay, so any mechanical device, okay, any device which converts heat energy into mechanical energy. ठीक है, जैसे आपका हीट एनर्जी को मैकेनिकल एनर्जी में कन्वर्ट करने के लिए जो डिवाइस यूज होगा, है ना, that will be your heat engine. Like in this case you can see that steam के through हम heat provide कर रहे हैं. This system is converting the steam वाला जो energy है that is into mechanical energy, and this system is rotating this particular object, right? तो rotation के लिए हमें क्या चाहिए? Mechanical energy, right? So this type of device is known as heat engine. Okay, Now, heat engine is made of three things. One is source, other one is sink, and third one is working substance. So source is nothing but the reservoir of heat. Source आपका क्या है? Heat का reservoir है at high temperature. आपका जो source होगा that will be at a high temperature and it has infinite thermal capacity. मतलब इसका thermal capacity इतना ज़्यादा है कि it can any amount of heat can be extracted from it at constant temperature. आप इससे चाहे जितना हीट एक्सट्रैक्ट कर लो इसका टेम्परेचर चेंज नहीं होगा. सिमिलरली सिंक इज द हीट रिजर्वायर एट लो टेम्परेचर. सिंक आपका जो होगा दैट विल बी एट अ लो टेम्परेचर एंड इट्स thermal capacity is infinite. That means any amount of heat can be given to the sink. सिंक को आप कोई सा भी अमाउंट ऑफ हीट दे सकते हो एंड द टेम्परेचर ऑफ द सिंक विल नॉट चेंज. नेक्स्ट इज वर्किंग सब्सटेंस. हॉट से कोल्ड या कोल्ड से हॉट के लिए जो हमें हीट ट्रांसफर करना होगा उसके लिए किसी से काम करवाना पड़ेगा, right? So for that we have working substance. So a material which absorbs heat energy from source converts it into work done and converts into work done और मैकेनिकल एनर्जी और रिमेनिंग हीट को अपने कोल्ड रिजर्वायर में अगर रिजेक्ट कर दे तो वो आपका क्या हो जाएगा? वर्किंग सब्सटेंस हो जाएगा. सोर्स का काम क्या है? हाई टेम्परेचर पे रहना है और दूसरी चीज इट शुड प्रोवाइड द इनफाइनाइट अमाउंट ऑफ हीट. सिंक का काम क्या है? लो टेम्परेचर पे रहना है एंड इट शुड एब्सॉर्ब द रिमेनिंग अमाउंट ऑफ हीट. वर्किंग सब्सटेंस का जो मेन रोल है दैट इज टू एब्सॉर्ब हीट फ्रॉम हाई टेम्परेचर, डू सम वर्क एंड रिमेनिंग जो हीट है वो वापस किसको दे देना है? to the cold reservoir, right? Now let's see what is the working of heat engine. So it is very simple, bachcho. We use gas as a working substance. So gas क्या करेगी? Let's say Q1 amount of heat will be absorbed by the gas. उसमें से W work done हो जाएगा and remaining amount of heat आपका जो होगा वो सिंक को ट्रांसफर कर देगी. ठीक है, टेम्परेचर किसी का चेंज नहीं होगा, फिर वो वापस अपनी इनिशियल स्टेट पे पहुंच जाएगी, राइट? ओके, फिर वापस वो Q1 अमाउंट ऑफ हीट हॉट रिजर्वायर से सोर्स से एब्जॉर्ब करेगी, कुछ वर्क करेगी, रिमेनिंग रिजेक्ट कर देगी सिंक को, फिर वापस इनिशियल स्टेट पे पहुंच जाएगी और ये प्रोसेस चलता रहेगा, राइट? सो दिस इज हाउ हीट इंजन वर्क्स. सो what is the thermal efficiency of heat engine? So thermal efficiency is very simple बच्चों. आपके पास कितना इनपुट था? efficiency is output upon input, right? Efficiency is output upon input. You are giving W output, you are giving W work done on account of Q1 heat. आपने Q1 absorb किया सोर्स से और बोला कि भैया मुझे Q1 हीट दे दो, मुझे कुछ काम करना है. तो बोले ठीक है आप Q1 हीट ले लो. So out of this Q1 heat you are doing some work W and remaining is rejected. Remaining is rejected Q2. तो आपकी efficiency is what? आपने आउटपुट दिया W divided by input Q1. Fine, but Q1 is nothing but W plus Q2, so you can write W as Q1 minus Q2. So you can also find efficiency as Q1 minus Q2 upon Q1, which is 1 minus Q2 upon Q1. Okay, so this is the thermal efficiency of a heat engine. Okay, right? Now if you are not rejecting any amount of heat from to the sink, that means Q2 का वैल्यू क्या हो जाए? 0 हो जाए. मतलब आपने जितना हीट सोर्स से लिया उतने का आपने वर्क डन कर दिया. If Q1 is equals to work done, जितना हीट आपने सोर्स से लिया उतने हीट से आपने उतनी एनर्जी से आपने क्या कर दिया? वर्क डन कर दिया. That means you are utilizing 100% of its energy. Okay, so thermal efficiency will be neta is equals to 1 or percentage efficiency will be 100%, right? But this is practically not possible. ओके वही हम सेकेंड लॉ ऑफ थर्मोडायनेमिक्स में देखेंगे कि अगर आप कुछ हीट लेते हो तो आपका कुछ हीट आपको सिंक में रिजेक्ट करना ही पड़ेगा. यू कैन नॉट यूटिलाइज योर 100% ऑफ हीट टेकन फ्रॉम द सोर्स. ठीक है, फाइन. So next is refrigerator. Refrigerator is the device which works in the reverse direction of heat engine. आपने कभी सोचा आपके आसपास का सराउंडिंग इज वेरी हॉट बट रेफ्रिजरेटर के अंदर का एनवायरनमेंट इज वेरी कोल्ड. ठीक है, आपका जो हीट इंजन है वो हॉट एनवायरनमेंट से हीट लेके वर्क डन करता है और कोल्ड एनवायरनमेंट में हीट को क्या कर देता है. यस, नीटा मीन्स एफिशिएंसी बेटा, राइट, रिजेक्ट कर देता है, राइट. बट इन रेफ्रिजरेटर क्या होता है, कोल्ड एनवायरनमेंट से जो हीट है उसको लेके विद द हेल्प ऑफ सम एक्सटर्नल वर्क डन हम हॉट एनवायरनमेंट में हीट को रिजेक्ट करते हैं बेटा, राइट. For heat engine, we take heat from source, do some work, reject the remaining amount of heat to the sink. In refrigerator, we do ulta work. We take heat from the cold source with the help of some external work and reject it to the hot environment. आपका जो कंप्रेसर है इन रेफ्रिजरेटर, दैट जो मैकेनिज्म है रेफ्रिजरेटर का, दैट विल प्रोवाइड यू द एक्सटर्नल वर्क. विद द हेल्प ऑफ एक्सटर्नल वर्क आप रेफ्रिजरेटर के अंदर से हीट को एब्जॉर्ब करके उसको हॉट एनवायरनमेंट में रिलीज कर देते हो. हॉट एनवायरनमेंट कैन बी योर रूम, है ना, सराउंडिंग. Fine. So refrigerator is a device which works in the reverse direction of heat engine. Okay. So for defining the performance of the refrigerator, we define one coefficient, that is coefficient of performance, that is equals to beta. Okay. Beta is nothing but heat extracted divided by work done. So refrigerator में क्या होता है बच्चों, sink is there, this is working substance and this is your source. ठीक है, फाइन. बोलते ना अगर रेफ्रिजरेटर में गैस खत्म हो जाता है तो वो कोल्ड नहीं कर पाता. सो गैस इज योर वर्किंग सब्सटेंस. यू आर टेकिंग सम हीट Q2 from the sink with the help of some external work and you are rejecting it to the source. Let's say you are rejecting a total amount of heat Q1 from to the source. So basically Q2 plus W is equals to Q1. So W will be Q1 minus Q2, right? So coefficient of performance is defined as heat extracted divided by work done, which is Q2 divided by W, or it is Q2 upon Q1 minus Q2. Fine. For a perfect ideal refrigerator, beta should be infinite. That means without any help of external source, आप सिंक से हीट एब्जॉर्ब करके सीधा सोर्स में रिजेक्ट कर दो. दैट मीन्स योर वर्क डन बाय द एक्सटर्नल सोर्स शुड बी जीरो. But this is not possible, right? For an ideal refrigerator or heat engine, you can write Q2 upon Q1 is equals to T2 upon T1, and this is the relation between coefficient of performance and efficiency of an heat engine. That is beta is equals to 1 minus eta upon eta. बच्चों ये questions जो है ना सीधे सीधे आते हैं, right? This expressions can be asked in the NEET exam directly. Beta is equals to 1 minus eta upon eta, right? Any doubt in this one बच्चों? Any doubt? ठीक है, चलिए बहुत बढ़िया. So we have one question for you guys from 2015 paper. The coefficient of performance of a refrigerator is phi if the inside temperature of the freezer, that is T2, temperature of the sink is minus 20 degrees Celsius, which is 273 minus 20, that is 253 Kelvin. Then the temperature of the surrounding, that is temperature of the source, will be क्या होगा. So you can use beta is equals to ये वाला expression Q2 upon Q1 minus Q2. Okay, and you can take Q2 common. So Q2 upon Q2 common, it is Q1 upon Q2 minus 1. Q1 से Q1 cancel. For an ideal refrigerator, Q2 upon Q1 is T2 upon T1. So it will be Q1 upon Q2 will be T1 upon T2, right? So beta will be 1 upon T1 minus upon T2 minus 1. ठीक है बच्चों, बीटा इज 1 upon T1 is I don't know, T2 is 253 minus 1 If you solve this one, you'll get your value of T2 as, देखो बच्चों calculation ये पूरा, if you solve this one, you'll get the value of T2 as 303.6 Kelvin. Convert it into degree Celsius by 273 से subtract करके, you'll get your answer as option D, which is 31 degree Celsius. ठीक है ना? Just try to do it one more time बच्चों. Okay, 31 degree Celsius will be the correct answer. Okay, next is second law of thermodynamics. So second law is for efficiency or coefficient of performance. ठीक है, second law of thermodynamics is here to criticize the machine. वो बोलता है कोई भी मशीन जो है that cannot be 100% efficient, right? Machine cannot be 100% efficient. Refrigerator without any external help काम नहीं कर सकता, right? So based on this, we have two statements from second law of thermodynamics. One is Kelvin-Planck statement that no process is possible which can completely convert heat absorbed from a reservoir into work. मतलब कहने का मतलब ये है कि let's say this is your source, this is working substance and this is sink. ठीक है, so if you are absorbing Q1 amount of heat, कोई भी ऐसा मशीन नहीं है जो Q1 को completely W में convert कर दे. Yes, it will be done by practicing बेटा. ठीक है, no machine is that much efficient जो Q1 को completely वर्क डन में कन्वर्ट कर दे. कुछ ना कुछ अमाउंट ऑफ हीट आपको एनवायरमेंट सिंक में रिलीज करना ही पड़ेगा, राइट? इफ यू आर नॉट यूटिलाइजिंग 100% ऑफ योर इनपुट इनटू आउटपुट, दैट मीन्स नो मशीन इज 100% एफिशिएंट, राइट? सो कैल्विन प्लैंक स्टेटमेंट ये बोलता है कि नो मशीन इज 100% एफिशिएंट. नेक्स्ट स्टेटमेंट इज क्लॉसियस स्टेटमेंट. सो क्लॉसियस स्टेटमेंट ये बोलता है कि यू हैव दिस रेफ्रिजरेटर, this is your sink, working substance, and this is your source, right? Sink is at lower temperature, source is at higher temperature. T1 is greater than T2, right? Refrigerator में क्या होता है? You absorb some amount of heat from the sink and release it to the source. Okay, right? So according to Clausius statement, a machine cannot absorb any amount of heat from cold and release it to the hot. हमेशा हीट का फ्लो हॉट से कोल्ड में होता है, ना कि कोल्ड से हॉट में, right? So अगर if you want to do reverse process, you'll take the help of some external work done. So without any external help done, you cannot transfer heat from cold to hot body. That is your Clausius statement. That means no refrigerator has coefficient of performance as infinity. Okay, किसी भी रेफ्रिजरेटर का कोफिशिएंट ऑफ परफॉर्मेंस इंफिनिटी नहीं हो सकता. केल्विन प्लैंक ये बोलते हैं किसी भी मशीन का, हीट इंजन का ईटा 1 नहीं हो सकता, right? So this is your second law of thermodynamic based on Kelvin-Planck and Clausius statement. Next is reversible and irreversible process. So a process which could be reversed in such a way that the system and surrounding returns exactly to their initial state. तो वो कौन सी process हो जाएगी बच्चों? Reversible. But any process which is not reversible is irreversible. Fine. If you are mixing two gases through certain processes और फिर वापस you can extract these two gases, तो वो आपकी क्या हो जाएगी? रिवर्सिबल. फॉर एग्जाम्पल आटा जो होता है उसमें अगर आप पानी डाल दो तो आप पानी और आटे को अलग नहीं कर सकते. सो दैट इज योर इररिवर्सिबल प्रोसेस. ठीक है, फाइन. सो कार्नोट इंजन इज बेस्ड ऑन द रिवर्सिबल प्रोसेस. ओके, एंड अगेन बच्चों कार्नोट इंजन इज लेट्स सी क्या होता है. वेरी इंपॉर्टेंट वन. This one is very important. Okay, so Carnot engine is the reversible engine which operates between two temperatures of the source and sink. Okay, and it is known as Carnot heat engine, right? So Carnot engine is the reversible.
सोर्स और सिंक के बीच में ऑपरेट करता है. ओके, दिस इज थियोरिटिकल इंजन बच्चों. दिस इज नॉट प्रैक्टिकल इंजन विच इज फ्री फ्रॉम ऑल द डिफेक्ट्स ऑफ अ प्रैक्टिकल इंजन. मतलब इसका एफिशिएंसी बच्चों 1 होना चाहिए, है ना. This is free from all the defects of a practical engine. मतलब this is your ideal engine. Okay. This engine cannot be realized in actual practice. But why do we study this one? This can be taken as a standard against which the performance of an actual engine can be judged. Okay, so कोई भी इंजन आप बनाओगे, आप देखोगे कि उस इंजन का जो बिहेवियर है वो कितना क्लोज है कार्नोट इंजन से, right? If the behavior of the engine is closer to the Carnot engine का behavior, then your engine is perfect. Fine. So we use this one as for the measuring the performance of the actual engine, right? Okay. So let's understand क्या होता है. Again बच्चों, we use ideal gas as your working substance. Ideal gas as your working substance. ठीक है. Source होता है at high temperature T1. Sink होता है at low temperature T2. We use one insulating stand. Okay, we use one insulating stand, right? ठीक है, चलिए, बहुत ही बढ़िया. So first of all, this piston और एक सिलेंडर होता है, ठीक है. The walls of the cylinder are insulator. Piston is also frictionless and insulator. Only the bottom of the cylinder is conductor. मतलब heat can pass through this cylinder via base only. Wall से कोई भी heat transfer नहीं होगा, ठीक है. Initially this Carnot engine का जो setup है, your cylinder and piston and ideal gas is kept at source temperature TH, ठीक है. सो हीट आपका ट्रांसफर होगा कांस्टेंट टेम्परेचर TH पे, सॉरी कांस्टेंट टेम्परेचर TH पे आपका जो गैस है उसका क्या होगा, एक्सपेंशन होगा, राइट. आफ्टर एक्सपेंशन वी कीप दिस सिलेंडर ऑन थर्मल इंसुलेशन. फाइन, थर्मल इंसुलेशन. फिर यहां पे क्या होता है, दिस इज थर्मल एक्सपेंशन, सो दिस इज आइसोथर्मल एक्सपेंशन. Then we allow adiabatic expansion without passing of heat. That is why the cylinder is kept on thermal insulation. ठीक है. After that हम इस सिलेंडर को सोर्स की जगह सिंक पे रखेंगे, है ना. टेम्परेचर इसका कम होगा एंड यहाँ पे इसका जब सिंक का टेम्परेचर अचीव हो जाएगा, इसका जो सिंक का टेम्परेचर है वो अचीव होने लगेगा और ये आइसोथर्मल कंप्रेशन होने लगेगा, राइट. एंड आफ्टर दैट वी अलाउ दिस थिंग टू एज एडियाबेटिक कंप्रेशन. ठीक है. सो कार्नोट इंजन है, that is nothing but the 4-step process: isothermal expansion, adiabatic expansion, then isothermal compression and adiabatic compression. फिर वापस सिस्टम अपनी इनिशियल स्टेट में पहुंच जाएगा. सो दैट इज हाउ इट बिकम्स योर रिवर्सिबल प्रोसेस. ठीक है, फाइन. सो वी हैव वन कार्नोट साइकिल, दैट इज द PV डायग्राम फॉर कार्नोट साइकिल. ठीक है. सो इन फर्स्ट स्ट्रोक curve, in first stroke the system is allowed to do isothermal expansion, like curve AB over here, A to B. Temperature is very high, T1 T2. At this point temperature is T1, at this point temperature is T2. So T1 is equals to T2 because ये isothermal expansion होता है and we keep the system on source. Okay, so in the first stroke, the temperature of the system is equals to temperature of the source based on the efficiency beta, right? Next one, like in the first one, the isothermal expansion is there and temperature of the system is equals to temperature of the source, and work done in this one will be R T1 ln V2 upon V1. Okay, V2 upon V1, V2 is the volume at this point and V1 is the volume at this point, and let's say this is the point AB, this is C, this is D, and if you connect this line with this line, this is G and this is E. So area under this ABGE curve is nothing but the work done in isothermal expansion. Okay. Next one is second stroke. Second stroke is nothing but adiabatic expansion. Curve B to C is adiabatic expansion. So area under this curve will give you what? Work done in adiabatic expansion. इसमें आपका temperature क्या हो जाएगा? Change हो जाएगा from T1 to T2, right? T1 to T2 temperature will change and the work done will be R upon gamma minus 1 is equal into T1 minus T2. Fine. Third stroke is isothermal compression, which is curve CD, C to D. इस कर्व के नीचे का जो एरिया होगा दैट विल बी द वर्क डन. इसमें क्या होगा कि आपका जो वर्क डन होगा दैट विल बी RT2, where T2 is the temperature of the sink, ln V3 by V4. Okay, V3 is the volume over here and V4 is the volume over here, and area of this will give you what? Work done in the third stroke. Fine. Similarly, fourth stroke is nothing but the adiabatic compression, D2A. Okay, so in this one, area under this curve will give you work done. So this is your work done, and that is R upon gamma minus 1 into T1 minus T2. So वापस आपका temperature T2 से क्या हो जाएगा? T1 पे हो जाएगा, right? So that is how this Carnot cycle works. This is the area. This is the graph of PV diagram for Carnot cycle, and total work done is given by the area of this curve, right? So total work done, entire process is area of this curve, right? So efficiency of the Carnot cycle is eta is equals to W upon Q1, and that is equals to minus 1 upon Q2 upon Q1. जैसे आपका था same efficiency यहाँ पे भी है. Remember the same expression, but this is your ideal engine, so you can write Q2 upon Q1 as T2 upon T1. So it will be 1 minus T2 upon T1, right? Efficiency of the Carnot engine depends only on the temperature of the sink and temperature of the source. 1 minus T2 upon T1 बच्चों. It does not depend on the nature of the working substance बच्चों. आप कोई सा भी गैस यूज करो, if T1 and T2 are constant, efficiency will be constant, right? And efficiency of the Carnot engine will be 100% if this T2 becomes 0 Kelvin. That means temperature of the sink is 0 Kelvin, then the efficiency is 100%, right? So which is ideally not possible. 100 Kelvin achieve karna ideally, practically it is not possible, right? So that is why no engine is 100% efficient. Okay, so like this is efficiency bacho, and these are the types of questions that may be that are being asked in the NEET exam बच्चों. This was in 2015 as well as in 2017. ठीक है. A Carnot engine having an efficiency 1 by 10 as heat engine is used as refrigerator. Carnot engine था, उसका efficiency 1 by 10 था, उसको हमने कैसे use किया? Refrigerator की तरह, which is work done divided by Q1. If the work done on the system is 10 joule, so 10 upon Q1 is 1 by 10. So Q1 यहाँ से क्या मिला? 100 joule. मतलब heat from the sink source is 100 joule. The amount of energy absorbed from the reservoir at lower temperature is. So basically for refrigerator, sink से आप energy absorb करोगे Q2, यहाँ से आप work done करोगे, right? And Q1 आप source में reject करोगे. So we have work done as 10, Q1 as 100. So you can look at this one कि work done plus Q2 आपको क्या मिला? Q1 मिला, right? So यहाँ से आपको Q1 क्या हो जाएगा? Q2 क्या हो जाएगा? The amount of energy absorbed. Okay, so Q2 will be Q1 minus work done. Q1 is 100 minus work done is 10, which is equals to 90 joules. So correct answer is option A, which is equals to 90 joules, right? I hope this is clear बच्चों. So that is how questions आपके आते हैं. पहले आप efficiency का formula use करके find the value of Q1, right? Work done is given Q1, then रेफ्रिजरेटर का फ्लो डायग्राम बनाइए, देन यूल गेट द आइडिया कि Q2 इज इक्वल्स टू Q1 माइनस W और सारी वैल्यूज एज इट इज पुट कर दीजिए. I hope this is clear, guys. Any doubt in this one? Any doubt बच्चों? नहीं? Great. So guys, again like this video, comment और शेयर दिस वीडियो विथ योर फ्रेंड्स, ताकि आप और आपके दोस्त साथ साथ कॉलेज जा पाए, राइट। एंड सब्सक्राइब टू आवर चैनल गाइस, बेल आइकन फटाफट से प्रेस कर दीजिए। एंड लेट्स चक दे, यस साई विग्नेश, वेरी नाइस, लेट्स चक दे दिस नीट टुगेदर बच्चों, लेट्स क्रैक दिस नीट टुगेदर, है ना। बस एक ही चीज आपको करनी है, दैट इज टू लाइक, कॉमेंट एंड शेयर एंड सब्सक्राइब, ओके। एंड नेक्स्ट टाइम विल सी विद द ग्रेविटेशन और करंट इलेक्ट्रिसिटी, दोनों के वन शॉट आपको बहुत ही जल्दी मिलने वाले हैं। सो बने रहिए इस चैनल पे गाइस, और कोई भी डाउट है यू कैन कमेंट इन दिस वीडियो, और कोई भी वीडियो आप उसमें कमेंट कर सकते हैं, विल गेट योर डाउट्स एंड विल ट्राई टू एड्रेस दोज डाउट्स ऑल्सो, राइट। सो थैंक यू सो मच गाइस, शेयर जरूर करना, लाइक जरूर करना, और सब्सक्राइब तो करना बनता है, ओके। ओके, हाउ टू प्रैक्टिस बच्चों, तो प्रैक्टिस के लिए जस्ट कोई भी बुक उठा लीजिए और उसमें से आप प्रैक्टिस करना स्टार्ट कर दीजिए, बट मेक श्योर कि यू आर प्रैक्टिसिंग फ्रॉम अ सिंगल बुक ओनली, ठीक है, फाइन। चलिए, सो टेक केयर एवरीवन, बाय बाय, आई विल सी यू अगेन वेरी सून, बाय बाय, बाय बच्चों।